This is what I call resonant regenerative looping. The 12-volt battery becomes part of the system. And as this charges itself up, this charges up with it, while your current and voltage stay the same. Okay, this is finally the intro for my new T2 design. I'm sorry to wait so long. You know, I built this thing like 3 months ago, but I've been experimenting with it for 2 to 3 months because I kind of stumbled on something, discovered something that it can do that's absolutely going to blow your mind. My original intention for this machine was to exploit what the toroids can do. I call it a T2, duh, obviously, because it's got the two toroids. But I've shown on the Q3 how I developed this new circuit that I call a disruptive capacitive discharge circuit. And with it, you can take a low voltage output from this thing, and about every 2 seconds, you can crank out 500 to 600 volts. So I thought, wow, man, that would be really cool to make a machine like this that could output, you know, maybe 1,000 volts or 1,200 volts. But then after you get shocked a few times, it sort of shocks the sense into you, and you go, oh, wait a minute. What's the practicality of this thing? To shock people? Well, that's no good. So I thought, okay, let's just use the steady stream output from these toroids, because they for the most part they circumvent Lenz's law, and you know, don't create that counter torque that you typically get when you're generating power through inductance. So I thought, okay, that's cool. Well, let's feed it into the system and see what it can do. Now, the second thing that prompted me to change my mind about the use of the toroids was what I discovered while experimenting with the stator coils. Now, these coils are bifilar coils, and there's 500 windings on the primary of each coil and 500 windings on the secondary. Now, between the sets, there's 12 coils altogether. Between the sets, we've got the equivalent of 24 coils, since we've got separate coils, essentially, from having a primary and a secondary on each coil. And so I decided, okay, well, I'll try hitting them both at the same time with the pulse, and yeah, I can get 1,000 RPM or whatever, but you know, the torque is pretty low, but that doesn't really do anything. So what I decided to do is I'd use the primary as for the pulse motor, and the secondary merely for output. And so I started experimenting with that, and that's when I made a very, very fascinating discovery that changed the whole course of this machine's operation. All right, let's go through a little rundown of the parts. Obviously, I've previously explained about the dual toroids and the stator coils. So next, I've got a amp meter here that only goes to 1 amp, because for the most part, you're going to only be drawing about 300 to 500 milliamps, though when the thing first starts up, you know, it only goes to 1 amp, but it may draw 1.5 to 2 amps. So I put a switch on here, and that's off, that's on, and that way you can start it up and then turn your meter on, and it'll be down where it should be without damaging your meter. Next, there's a couple of bridge rectifiers for the output. Next to that, we've got a couple of quick connects here that say, the label says 12 volts in. This is negative, this is positive, because this is a 12 volt machine. The reason for that is the next item over, which is a DC to DC converter. It operates from about, I think it kicks in about 10.5 volts, something like that, and you can feed into it up to probably 14, 15 volts, something in that neighborhood. But it'll allow you to operate up to 30 volts, but even though it'll go to 31 or 32 volts, these heat sinks will get a little bit warm if you push it over that. But typically, if you're running 1/2 amp, you don't even feel these warm. Nothing's warm. This isn't warm. Not the capacitors aren't warm, but so it does its job really nice. And right here I put a little plastic knob on here, and I plan to try to do that for all the kits too. By the way, if you buy this in the kit form, it'll come pre-populated with all the electronics on here. All you've got to do is make the connection. So I'm trying to make this thing as easy as possible, and I'll tell you, it's, you know, I've designed it as kind of a set it and forget it machine, but we'll go over that in a minute. Okay, next over you've got your switches. There's your power on, and right now I've got ultra caps in the back. I'm going to explain that in a second. And that shows what there's 2 sets of ultra caps. There's only 6 of them in each set, so it's small. This is for your run set, and then this is for your charge set. Now you've got, it's in series parallel, so your run set is isolated by itself, and then for the charge set, they're in series, so we've actually got 27.4 volts. The blue LED here indicates that it's ready to start. I mean, all you have to do is hit this one. The label says coil on. Bam, coil on, there it goes. So you can see what the power is doing. All of a sudden, whoa, the voltage jumps up because, let me just turn it off now for a second, because we'll go over that also. Because what it's doing is it's feeding every bit of its own power back to itself. And there's a real good reason for that that you're just going to love. It's just so cool. So okay, so anyway, so that's the 2 meters here, and then you've got your solid state relay. Now on this design, there's no adjustable timing ring, so you don't have to mess with that. It's in a fixed position. All your adjustment is going to be done through the DC converter here. And you're going to come to one adjustment and pretty much just leave it at that adjustment, and that I'm going to explain to you why as well. All right, so let's just come down here. Well, also we've got a couple of bridge rectifiers here. I don't know if you can see this without me zooming in, but it says 12 volts out for this one, and on this side here it's 24 volts out for this one. So you have a choice. If you want to charge 12-volt batteries in parallel, or 24 volts in series, either way you want to go. And not only that, but you can adjust this up, and I will also show you that if you want to charge faster, or you want to bump up the current output of this thing, and the voltage output. So, all right, let's go to the back here. All right, here we go. Now, this is your run bank. Oh, by the way, these are, again, Maxwell. Love these products. I've been experimenting with ultra caps for years, and ever since I realized the advantage of them, especially in a hybrid situation. I mean, look around you. Everything is going to incorporate these things. It's just so great because they can charge up and unload that charge at just a second's notice if you need it. But as a buffer for charging and discharging, you just can't beat them. And you know, they've got 350 farads in each cap of capacity, so it's pretty good. So this is the run one, and then this one, if you're charging on 12 volts, this is the one that will balance out that output. And because when the system is running, it's feeding the power in a 24 volt method, so because these are in series, and so each bank charges up while the thing's running. Now this is nothing more than AA batteries that are, let me grab this. They're just these rechargeable Duracells, and 2650 milliamp hours. Yeah, so they're pretty good, and there's 10 in there, so I can get, you know, maybe 13, 14 volts out of those. And what they do is, as you're drawing power out of the this primary cap bank that runs the pulse motor part, they will, let's say your power fluctuates because I'm going to show you that this is a totally green system where it ties in with a tiny solar panel, because most of the time you're going to be demanding about, less than 15 watts. It runs without being under load, I mean, while it's charging itself, on less than 4 watts. And then when you connect some batteries, I think it takes it up to about 8.5 or 9 watts, something like that. And that's pretty much where it stays. Okay, a couple of other very quick things I forgot to mention. Very important parts, actually. This right here is an inline fuse for the power input, and it holds glass fuses. I've got a slow burn 3 amp fuse in here, and that'll keep you from, in case you accidentally connect the output backwards or something, whatever, you make a mistake, instead of losing your nice little expensive DC to DC converter and your solid state relay and maybe your meters, it just blows this little fuse. So you just take the end out, pull the fuse out, stick a new one in, and you're good to go. The other thing is, on the DC converter itself, there's a 15 amp fuse, so obviously, you know, you can see that this thing can really take some load coming into, or some current coming into it. But you know, you're never going to really put more than, at the maximum, 1 amp into it. Most of the time it's just like half an amp or less. So that's why the transistors that are on the heat sinks, they don't even get warm. This one, sometimes you can start to feel that getting a little bit warm. This one always pretty much stays cold. So one final thing before we move on is, please forgive me if I talk too fast or I fumble up my words, because there's so much to cover on this, and I'm just trying to do it quickly so it doesn't make this video too long. Let me just back up real quickly here to clarify something and cover these cables one more time. You don't have to have a solar panel. You don't have to use that if you don't want to. I mean, if you've got, if you just want to bring in battery input in here, even if you don't use a battery, once the ultracaps are charged up, they'll run the machine and charge batteries on their own for at least a couple of hours. But you know, you want to use something that brings in a little bit of input, so the thing will just keep on going. I don't care if you've got a little bit of wind power, maybe you've got some hydroelectric or geothermal or tidal or plutonium. I don't care what the heck you got. But you should use something. But the idea was to use something really cheap and keep it very, very portable, to keep this system in a totally renewable configuration. The idea with any of this stuff that I'm designing, we need to stay off the grid and try to utilize a system that will just be reliable for us, you know, 24/7. Okay, so again, on the cables, just real quickly on the cables. This, of course, is the output cable with the connection on the end for the solar panel, and it's, I don't know, 10 or 12 feet long, something like that. Okay, then this is just a connection cable here that plugs into the end, and then these quick couples, cheap quick couples, and that cable with these couplings came, you know, with the solar panel. But these you just buy, they're really cheap at the store. I made this one custom. You don't have to use this, but the idea was to plug this cable in and take the one end and plug it into this end here. And these clip on to a battery, 12-volt battery, and then the other plugs that come off of that go straight in to, brings it straight in from the battery to your input here. So you're going from the solar to the battery is storing that power, and then going from the battery into your input, and so you can charge and run 24/7. And that's a great way to do it. Now this is just a cable that I put together. These battery clips, one pair of these will come with each T2 kit, and then the rest of this is optional, whatever you want to do. But this way, this just plugs into either your 24-volt and 12-volt and clips onto your batteries, and away you go. So again, optional, or you can just take this panel and connect this here to your output and plug it directly into this. But you're only going to be, you know, working during the daylight hours, even though that amorphous crystal panel will work when it starts to get dark even. I mean, it's amazing under these lights that it produces 13 volts, just under fluorescent lights. But But it's cheap, it's easy, and it's renewable, and I would suggest that. I want to show you first, without it connected, with this plugged in, what the machine is drawing from your input, whatever your input may be. So let's turn it on, power on, and coils on. We're running. Okay, you can see the voltage immediately comes up, drops back down, stabilizes 13.6, 7. Okay, and there's our charging current. Though I'm going to turn this meter off because it does draw a little bit of power, but hardly any. But we don't need it now because if when I unplug this and plug this meter in, you're going to see why I need to turn this one off. We're drawing about 325 milliamps. It probably looks like more from this angle, but I just wanted you to see all the setup. So about 325 milliamps at 14 volts. And so we are drawing 4.55 watts to run the machine. Let's unplug this and plug this in. 144 volts. Yeah, it's respectable. Okay, not bad. But we're only running at 14.1 volts. Now, we take the DC converter and we dial it up. Now watch our voltage here as we increase the input voltage through the DC converter here. And also, this is going to rise and then come back down each time. You can see when I make an increment of adjustment up on the voltage, the needle goes up and then comes back down. 159 volts. Well, it's getting better. I'm going to take it right to the point. Alright, this is kind of the sweet spot here. 180 volts, maybe a little higher. Let's try it. Okay. That's why it just takes a little bit of adjustment. It's 180 volts. 180 volts of output. Well, that's interesting. If you turn it down, it's going to drop just like it was before we turned it up. Okay, if you turn it up past this point and increase the voltage from 23.4, let's take it up to 25 or something. You saw it go up, it went up to like 185, but now look at it. It's just coming down and coming down. And the higher the input voltage that you go, the lower your output voltage is going to be. 26, let's just yank it up to 30 volts. Look at it. It's down to where it was when we started with 14 volts. Less than that. That's crazy. What is it? Why is it doing that? This is the best part. Because the primary and the secondary coils and the bifilar coils are resonating at the 23.4 volt input, and the low current that they're pulling, 300 and some odd milliamps. Let's take it back down there. 23.4. Oops, 2, 3. It's really fine to adjust this, but you get it there. But you just tune it to whatever it is consistently, and you're in resonance. You get this 180 volts. This is in resonance. Now, you got to also understand that the secondary on the bifilar coils, every time that rotor with those N52 magnets passes one of those coils, any of the coils, you're going to get some inductance. So you get a little charge coming off of the secondaries from that. Primaries we're just using to run the pulse motor. So then also when the primaries fire and they pulse, you get a little burst of mutual inductance into the secondary. Okay, that comes straight to the output, which goes into the caps and then into your charging banks. And then when the pulse terminates and you get that inductive spike that explodes in those primary coils, then that mutual inductance of that spike just transfers right to those secondaries. Bam, it comes right back out. And this 180 volts this is not through capacitors. These are not These are not affecting this right now. 8.73 watts at this point. Now the interesting thing is, let's unplug this, plug this back in. Okay, now it's charging itself, and so the meter doesn't make any difference at this point, but we've dropped down to 360 milliamps at 23.4. So it's roughly about the same. It's a little less draw, but the best part about this is when you connect a charging load, batteries, 24 volt, 12 volt, this figure will stay the same because of the resonance that's going on here between the input and output on the primaries and secondaries. That's just incredible. It'll just stay right at this point while it charges up those batteries. So every battery that you add to this system becomes an extension of the system itself. It works through the ultra caps and the batteries. It's just the most amazing thing. I've never seen that before. Usually, if you're going to charge up some batteries, you're going to see the current's going to rise, your voltage is going to fluctuate, or whatever. But it doesn't. It doesn't because of this relationship up here. And you know, the same time that you're getting that full output from those secondaries, we're not even pulling anything from the primaries. I mean, here's the spades for that on the bridge rectifier. We're not connected to anything. You could charge something, but it's low. It's like I don't know, 8 volts and whatever the current is. It's just low. So we're not even using that. So we're just using the secondaries of the bifilers and getting those 3 different outputs, you know, from the rotation that I just explained. And plus we're getting from the toroid a consistent, nice, smooth output. It may be low voltage, but the current's going to be a little bit higher, and that's 16 gauge wire. And you know, it's not slowing the machine down at all, even with 2 of them. So you've got some pretty interesting things going on, and extending the system with the batteries for charging, just incredible. Okay, last demonstration. I've drained this 12 volt battery down, let it stabilize for a while. It's still trying to rebound a little bit, but it's at 12.3, and I've got it connected to the 12 volt output, and we're going to run it this time with 2 little 6 volt lantern batteries in series for 12 volts into the input. Turn the power on, coils on, 12.3. Okay, now let's bring it into resonance. .3, 23.4. Oops, too far. Okay. Turn the meter on. We are drawing just under 400 milliamps, 23.5 volts from the input at about 400 milliamps. Now we're going to disconnect the input. .400 milliamps, 23.5. Charging is coming up. Caps only. Charge is coming up on the battery. Still running on the caps. Let's plug our input back in. Now you can see we come back up to less than 400 milliamps, and our voltage drops back down to stabilize, and our charge rate continues. Check us out at quantummagnetics.com if you're interested in obtaining a kit to build this. It should be pretty simple to build. with this already set up for you, just making the connections and you know, nuts and bolts. It's a pretty simple situation. We've got good manuals, easy to follow, and free tech support. So have a look at quantummagnetics.com. Thank you.